So hello guys, let us see the third question from today's contest. And it is the same problem, which was the first problem, shortest subarray with or at least k. But this time the constraints are a bit tricky, are a bit tight, or you can say. So the normal n square approach won't work. And we have to shift to standard two-pointer approach. So after n square approach, sub-array problems are generally solved using two-pointer approach, in which sliding window approach, in which we have two pointers I and j, and we increment j, and then when the condition is satisfied, then we try to increment I and decrease the sliding window. So something like this, also something like that only we have to do, but we have to maintain the bitwise OR. Now the intuition of these kind of problem is that first you do the thing, then you undo the thing. For example, if the problem was shortest subarray with, let's say, minimum sum at least k, then we will add on in our answer and then we will decrease. But the problem here is we have a bitwise OR. So we have to find a way to complement that OR. Because, okay, let us see what I trying to say. Just a second. Yeah. Because we can see that suppose this is our array, and then we are, let's say this is element 1, this is 2, this is 3, this is 4, this is 5. Then we are ORing, we are taking OR, but when we will reach the condition when OR is greater than equal to k, then we have to increment our I from this side, and hence we need to nullify the effect of this element. So this was the catch in this problem. So now how we can do that? See. Okay, let us iterate through the code only. So this is standard template of two pointer. Well, while j is less than n, we will increase j, and when the condition is satisfied, we are doing something with the I. So now first we will OR. As mentioned, first we will OR. We will use a frequency array. Now what a frequency array will do? A frequency array will keep a track of the bits. Yes, of the position of bits, the number can. So it will have the positions of the bits involved. Like what is the frequency of the bits involved? Okay, because we know that in OR, only the bits get added up. They are not subtracted or reduced in any way. So we will simply keep the track of the bits. Now, when the answer is greater than equals to k, in order to reduce, now we need to reduce the answer. First of all, we will take the answer, which is j minus I plus 1, and we will take the minimum. We will initialize this answer, which is num element I have initialized, to int max, and we will take the minimum of j minus I plus 1 and num. Now we need to nullify the effect of OR. Now we can do a XOR, but XOR can nullify the effect of OR. But now for that only, we have created a frequency array, because it might happen that a particular position, one at a particular position, is not only due to a particular element rather than many elements. For example, I have a 1 and I have a 3. Now, ORing these two will give me this. Now, let's say I reduced 1. I reduced 1. So, I XORed it out. So I will get something like this. Now, but 3 was there. So I should have this one. But I lost it. So this is where frequency array comes into picture, and you calculate the frequency. Now, if the frequency is Yes, if the number was nums of I, this expression is used to calculate the bit number. And then we calculate if that was the bit, then we reduce its frequency. If IT was the bit, then we reduce its frequency. And if it is still greater than 0, then we OR it up again into our answer. For example, in this case, the frequency at 0 will be 2, but we reduced 1. So 1 we need to add it back. 1 we need to OR it back, you can say. So this is how we are ORing it back. Finally, it is I plus plus and j. So yeah, guys, this was all from this question. It was a good question. Thank you so much, guys, for watching this video. Just in case you like the video, like the question, make sure you hit the like button, press the subscribe button, and share it with your friends. Thank you so much, guys. We shall see you next time.